Hi, I'm Vinod from Dell Technologies. In this demo, we will see how to protect the Rancher Kubernetes cluster RKE2 workloads such as namespace and PVCs using PowerProtect Data Manager that are deployed on Apex Private Cloud. Before proceeding with data protection, we will briefly explore the Rancher Kubernetes cluster setup. This is the high-level overview of the setup for this demo. This is the Rancher Management Server UI. We see there are two custom RKE2 clusters and a local Rancher Management cluster. The provider is RKE2. The Kubernetes version is 1.23. The cluster RKE2 Class 002 has 3 nodes, where one node has all the roles and other 2 are worker nodes. Let's verify the other cluster configuration. The cluster RKE2 Class 003 also comprises of 3 nodes, but all the 3 nodes have all the roles. PowerProtect Data Manager can be integrated with both these clusters and can protect the workloads. In the case of custom cluster RKE2 Class 002, PowerProtect Data Manager can be integrated directly with the downstream cluster node, Cluster 2 Node 1, which has all the roles. In the case of custom cluster RKE2 Class 003, each node has all the roles. Considering in terms of high availability, PowerProtect Data Manager can be integrated with this cluster through an external load balancer. For this demo, we will explore and protect the workloads in this custom cluster RKE2 Class 003. And for the persistent volume for this cluster, we have vSphere data store from Apex Private Cloud Services, which is integrated using the vSphere CSI driver. As mentioned earlier, we have 3 RKE2 nodes and each node has all the roles. Hence, I have deployed and configured an external load balancer to act as a front-end endpoint for these RKE2 nodes. And through the load balancer, we can integrate this cluster with PowerProtect Data Manager and discover the namespaces and PVCs for data protection. As a prerequisite for successful authentication of PowerProtect Data Manager with the Rancher Kubernetes cluster through the load balancer, we need to add the load balancer details to this cluster configuration file. I have already added the load balancer details to this cluster configuration file. To verify the same, navigate to the hamburger icon. Select Cluster Management under Global Apps. Select the cluster RKE2 Class 003. Click on YAML. In the TLS SAN section below, we see there is a load balancer FQDN entry. For more detailed steps on how to add the load balancer details to the cluster configuration file, refer the white paper link below. For this demo, I have deployed a MySQL application in this cluster. Navigate to the hamburger icon. Select RKE2 Class 003 from the Explore Cluster section. Select Workload. Click on Deployments. We see the sample MySQL application that is available on this namespace SQL Class 1. Select the deployment. We see the MySQL application pod is running. Also for this demo, I have created a sample database and table in this MySQL application. Let's explore them from the command line interface to this cluster. These are the 3 RKE nodes available on this cluster. Each node has all the roles. We see the namespace SQL Class 1, which has the MySQL application pod running. Let's get the pod details. We see the MySQL application pod running. Let's connect to the application. We are now connected with the MySQL database. For this demo, I have created a sample database called Student Details. This is the sample table that I have created on this database. We will now protect this corresponding MySQL application PVC and namespace with PowerProtect Data Manager. Let's navigate to PowerProtect Data Manager UI. From Infrastructure, select Asset Sources. I have already integrated both the custom RKE2 clusters with PowerProtect Data Manager. The asset source with name K81 is the custom cluster which has 3 nodes, where one node was configured with all the roles and other 2 are worker nodes. Hence, I have integrated directly with the downstream cluster node which has all the roles using the cluster service account token. The asset source with name RKE2 is the custom cluster which has 3 nodes, where all 3 nodes have all the roles. Hence, I have integrated this cluster with PowerProtect Data Manager through a load balancer using the cluster service account token. Please note that the external load balancer configuration is required in the backend before integrating with PowerProtect Data Manager. Once the integration and discovery of the cluster is successful, the namespaces and PVCs are available as assets for protection. In continuation to our demo, let's protect the namespace SQL class 1 and respective PVC which has our MySQL application running. The SQL class 1 namespace belongs to the cluster RKE2, where we have integrated the cluster through the load balancer. Let's create a protection policy to protect the respective namespace and PVC. Navigate to protection, click on protection policies, click on add, enter a name for the protection policy, select the asset, enter the retention details, review the summary and click on finish. The protection policy configuration is now in progress. The protection policy configuration is now successful. We will now perform a manual backup. Navigate to protection, click on protection policies, select the protection policy and click protect now. We will monitor the backup job from the protection job section. The manual backup is now in progress. Let's wait for the backup to get completed. The backup has been completed successfully. We will now verify the protection copy. Navigate to restore, click on assets, select the namespace, click on view copies, select DD. The protection copy is now available and ready to restore. We will now perform a restore for these MySQL PVCs from the backup copy to a new namespace and verify the data. Click on restore, select restore to original cluster, select restore namespace and select PVCs, select restore to a new namespace, enter a name for the new namespace, click next, select the PVC, review the summary and click on restore. We now see the restore job is in progress. Let's navigate to cluster CLI and check if the namespace has been created. We now see the new namespace SQL class 1-restore has been created successfully. Let's navigate back to PowerProtect Data Manager UI and monitor the restore. The restore is now successful. Let's verify the same from the cluster CLI. Now see the MySQL application pod running. Here we go. The same database, student details and the respective table that was created on the original application pod belonging to the old namespace is now available with the restored namespace. This confirms the successful backup and recovery of namespaces and PVCs that are available in Rancher Kubernetes cluster using PowerProtect Data Manager. For more details, refer PowerProtect Data Manager for Kubernetes white paper and see PowerProtect Data Manager and SUSE Rancher website. Thanks for watching this demo.